Azure meetup. This year we will do a new series. Every month there will be a meetup, and this will be the first uh, of 2025. I have the pleasure to introduce you to Deepti, who will talk with us about um, SQL and all the things that you need to do in order to make sure you have high performant queries. One of the issues I had a couple of weeks ago was that we had a SQL server that didn't do what it should do. So I hope to learn something this evening, and I hope you will do too. If you have any questions, just leave them in the comments, and I will make sure to get back to you as soon as possible. Without uh, any further ado, I'd like to introduce you to Deepti.
Hello,
Hello,
everyone. Hello, Daniel. How are you?
I am good, thank you, and I hope you are as ready as I am to get the show on the
Yes,
road.
I am. I am.
Um, Please share your screen, and I will make sure to hide myself and give you all
Sure.
the room.
Screen. Hmm. So just let me know when you can see it in the presentation mode. Are you able to see?
Yes, yes, it
Awesome,
works.
awesome. So hello everyone. Thank you so much for for taking your time. I do not know where you are joining from. Maybe from India, Netherlands, America, I don't know. So welcome. Welcome to Go Azure Meetup Group. And thank you so much, Daniel, for giving me this great opportunity to be presenting about one of my favorite topics, which is Query Store. Query Store is a feature that comes with the SQL Server engine. So any of the audience who are watching this recording today, video today, we are live actually. So um, if you are not familiar with this feature, do not worry because I'm going to talk about from the basic all the way to what Query Store can actually do and how it can help your queries. So without any further ado, let's get started. A little bit about me. I'm a database administrator. Also, I'm a Microsoft Data Platform MVP. It's been 2+ years being in the program, and also I'm a co-organizer and co-organizer for a couple of user groups. I'm a co-organizer for Data and AI South Florida user group, Data Platform Diversity, Equity, and Inclusion user group, and also I'm also co-organizer for the Cloud Data Driven user group and also Data TGAF. And also, I'm a co organizer for the Future Data Driven Summit. It's an online conference that we do every year. So, if you are interested, please go ahead and look into it. And also, apart from that, I love exploring myself within, which is related to philosophy and non-duality. If you search in Google about non-duality, you'll know what I'm talking about. So yeah, it includes quantum physics and everything. It goes deep into like, what is your life? Why are you here? Who am I? Right? Those sort of questions. So I just love exploring, and also I do blog on bbnuggets.com. That's my website. I do usually blog on SQL Server and Azure topics. So if you like, please go ahead and visit. Um, so if you're on social media, these are my platform where I do um, I'm active on most of the part on LinkedIn and Twitter. And also I have all of my slides and everything on GitHub. So if you can scan the QR code, it will directly take you to the link. So I hope to get you to get connect with you. So I would like to um, take this over to our session with a small on-call incident that I had recently. I'm a DBA, so every month I will be an on-call at least for 1 week. So, um, so this was my incident details. In the morning, I believe it's early in the morning, 2 a.m. in the morning, I received a pager on my phone. I was in the deep sleep, so I was panicked to see the incident details mentioned in the ticket, right? It's a priority one ticket and it mentioned like this. View is taking forever to run and failed finally. View means SQL Server database view, right? That is taking forever to run and failed finally. Several months ago, Deepthi did something using Query Store to fix this issue. The issue was resolved and then reoccurred again now. Could you implement the same steps to fix the issue? Now, this issue I have fixed at least 8 to 9 months ago, right? And I don't even know what I did and how I fixed that issue, but I somehow used Query Store to resolve the issue. So, this was the error that they attached to the instance. The query processors ran out of the internal source resources and could not produce a query plan. Now, this sort of error you usually don't see in SQL Server because most of the times SQL engine will figure out a way to get back you the results. But this time, it's very rare scenario. Even if you type this error in Google, you find very few because SQL Server said like, nope, I'm done. I can't produce the query plan. I can't run this query. So that is what it is saying. Usually it won't do because SQL engine is taking too many resources to run. So this query was running fine when I initially fixed it. So I was like, "Woo! I fixed the issue at least couple of months ago." But when and how? Because it's been a while. It's been at least 8 to 9 months. So I'm like, I felt proud a bit, but then fall back to the trap again and not knowing where do I start now. So digging into the details, you all know how we search if we have to find something out, right? Outlook email search on the string and then aha, I found that I created a index with the help of the query store. Initially 9 months ago I did created an index which resolved the issue, right? But then if I created the index, it should work fine and I don't have to do anything, but why did the issue reoccur again? Now, developer was with me 2 a.m. in the morning, and they were like banging their heads. Did they do something or did DBS do something? So they were waiting patiently on me to tell the answer. But I was like asking them the questions, like, did you change something or like did you release some code or like what's going on, or like the plan that you were using, did something change in the plan? Like, so did somebody deleted the index or what? Within the plan that's being used. They said like nothing changed, Tripti, nothing changed. So I thought like, okay, let me go ahead and open up the query store and see the details. So I know the database name, I know the query because I checked with the developer. I asked developer to give me the query. So what I did was I used the query store to view and find the query ID. So query store is a feature where once you enable it on the database, it's a database level feature, not the server level feature. So once you enable it on the database, it will go ahead and collect your queries and the execution plans and all sort of like what resources it used to produce the results. All of those information will be visible in the graphical user interface as well as by using the views, query store views, system views, right? So I pulled it up by using the graphical user interface query ID, uh, or like I can also do that through view. So if I remember correctly, I used the query store view and find the query ID, and then I check the query itself. The query itself is an ad hoc query. Now, if you know the ad hoc queries, no matter even if you add a small space or like change the parameter value, or if you pass a little bit change or pass a digit, query itself remains the same. But if you change something, then it will generate an entirely new query ID. It's not good because the query store will actually look for those query IDs. And if there is a new query ID every time the query runs, then it will blow up the query store because once you enable the query store, you have some space inside the database especially allocated to query store, and if you keep on running the ad hoc queries it might blow up the query store, right? So I said like, this doesn't seem right. Like we fixed this issue, but something is going on here. So first thing, it's an ad hoc query, right? Not good. And explicitly they are including extremely large number of values within a in clause. So they are searching on the in clause, And to my surprise, they are putting every single value from the table. So the table itself, when I did select star, it just bought like 3,000, 4,000 records, and almost all of the records they were searching in the in class. So I was like, no, this is not the way you do it. Instead, just pull in all the table, right? Instead of searching on that in class. So because it is an ad hoc query, we can't even force the plan. So one of the advantages of using Query Store is that if you find a query, let's say store procedure, having a plan which is working awesome, and then later down the road, some other plan kicked in and it's not running fine. With using Query Store, you can go back and see what it used to work before, and also you can see the execution plan and you can force from there, force the plan that is working well, so that the next time you run with no matter what parameter you use, that the plan that you force will kick in. But here we can't use the force, we can't force the plan, because every time the query runs, the id is keep on changing. We can't force each and every id, right? So the workarounds on this one is like two workarounds are possible. So I said like user select subquery within an in clause, or remove the where clause completely and pull in the entire table in the memory on the console app server itself, because it's an ad hoc query. They are running in from the ad hoc. So I told them like, why won't you pull it the entire table and put it in the memory? So they decided to go with the second option, which is feasible. They did select star, and the query ran very quick within fraction of seconds, and the problem never occurred again, right? Because we fixed the problem permanently by using the query store. We got the details, all the details from the query store. So how the query store actually helped me, right? In this process, it helped me to identify the query very quickly, and what sort of uh, resources are consumed by that query by using the top resource consuming query list. That's a report that you'll get once you enable the query store. So I used that. And also, I initially solved the problem by creating that index suggestion. As it is an ad hoc, that is why I cannot force the plan. If it is not an ad hoc, or if it is a store procedure, I would have definitely used the force plan. Advantage. I used to take the advantage of the forcing a plan. Again, forcing a plan is a temporarily fix. Now, if you see how I worked with the developer to fix the issue, we actually fixed the actual problem itself. We did not cover it up or just force the plan, because once you force the plan, um, you will actually need to force the plan just as a temporary resolution, because the permanent problem is like within the query itself. You need to check why the query itself is behaving weirdly, but you will not have all the time the advantage and like privilege to go ahead and change the code when the code broke in the middle of the night at 2 a.m. in the morning, right? So that's when the query store will actually help to fix the issue very quickly, so that later down the road you can fix the problem permanently. But until then, you do not have to put your application down. So I was also able to see the entire query and its plan over time. And that's how I thought like, this is an ad hoc. That's why we have like these many query IDs. No, the plan forcing doesn't work on this. And it helped me made decisions quickly, because as I was able to see the query itself, and then how the resources are being consumed by using the query store information, I was able to tell them that they can just pull up the entire select star by using the entire. You can pull up the entire table instead of like searching by in class. So as an agenda, what I'm going to do today is I would like to show you the evolution of the query store, fundamentals of it, and a couple of benefits of using query store. And if we have time, I will also show you the advancements in SQL Server 2022, and couple of best practices and things not to forget. And finally, the demo will come in between, right? I do not want to show it at later on after completing the session. So the query store fundamentals. Query store is a feature, right? It comes with the SQL Server engine itself, and it got introduced in SQL Server 2016, and they keep on adding the additional features on the top of it. But it is also available in Azure SQL database, it is automatically enabled right by default, and it is automatically enabled by default from SQL Server 2022 if you are creating any new databases on that environment. It is also available in Azure SQL Managed Instance, Azure Synapse Analytics, but only dedicated SQL pool only. And you can't enable the query store on master or tempdb. Now, why do you use tempdb? Every time it gets restarted, right? So we do not need query store on the top of it. But if you can enable it on database, like if you want to create any new database, it will get all those details and all the default settings from the master anyway, so you can set the query store on the master database. But think again, because if you are creating a database and it is going to be a huge database, and then you are taking the template from the master database, you might be have to tweak in the configuration settings based upon that big database, right? So but you can still enable on the master, sorry, not master, but model database. You can't enable it on master or tempdb. So the evolution, if you see, as they introduced in SQL Server 2016, once you enable the query store on the database, the query text, the query plans, the runtime statistics information that you collect after executing the query, those statistics information will also be collected, and graphical user interface are available to view all of this data. And also in 2016 itself, they introduced plan forcing so that you can fix a problem very quickly and then work on the code later with the developer. And in SQL Server 2017, they added one more additional feature for the enterprise editions only, which is automatic plan correction. Now, what this will do is instead of you going manually and changing, forcing the plans and have a plan forcing, it will go ahead and automatically do that for you. Once you enable automatic plan correction, and once you are in the enterprise edition of SQL Server, or in Azure. If you are in Azure, automatic plan correction is automatically enabled by default. So it will go ahead and look for your queries, and then it will go ahead and always make sure your queries are having the last good plan turned on. Now, if there is a regression meaning if there is a low performance after the automatic plan correction selected a plan, if there is a low performance later, that's when it will always make sure it chooses the plan which is always good plan, right? And uh, they also added per plan weight stats information. And in SQL Server 2019, they added custom capture policies. Now, until now, SQL Server decided for us what kind of queries can be captured in the query store. Now, it depends upon how many times the query runs, how much of a CPU threshold it have to hit to enter into the query store. That information is not given by Microsoft before SQL Server 2019. Now in SQL Server 2019, you have the ability to go ahead and choose what sort of a queries you wanted to collect, how many times the query have to run, how much of a CPU threshold it have to hit, those sort of things, right? And plan forcing also is enabled for the cursors from SQL Server 2019. So what data it can collect? It can collect, select, insert, update, delete, merge, and bulk insert, the DML statements. What it does not collect is DDL statements such as create index, etc. And whenever it collects the information, it doesn't collect the information based upon one execution. It always collect the information as a cumulative resource consumption. So we have certain like for example, I will talk about that later, but we have intervals, something known as intervals. Within that intervals, no matter how many times your query runs, a single query, how many times it runs, it will collect the information as a cumulative information and allocate just one row within the query store. Because why? If we do not do that and if we collect all the information, each row for one execution, query store will blow up. So we do not want that, right? We want to take the advantage of query store, not to drain more resources and kill our server. So that's the reason they do the cumulative resource consumption information. So how query store actually works behind the scenes? Now we need to know this before knowing how to use the query store. Very important to know. Do not think like, why do I have to learn all of this internal stuff? Now internal stuff is very interesting, and to know a product, if you know the internals of it, it always gives value, right? You can look back and see where the issue is coming from and how to fix it if you exactly know where to look. That will happen when you know the internals. So let's start with how the query actually runs on the SQL server. So whenever there is a query, any sort of query, right? Whenever it is running on the SQL server, the SQL engine will first check if it is running for the first time. Now, if it is running for the first time, then it will go ahead and see if there is like if it is running for the first time, then definitely it will have to go and see the compilation and optimization. It have to run through certain phases to build an execution plan. Without an execution plan, your query doesn't run. So it has to first build that and then execute uh, based upon the plan. Now, what if it is not running for the first time? Now it will go ahead and check whether there is already an execution plan for that query in the cache. Now, if there is no plan in the cache, there can be the reasons of why the plan is not in the cache, even though the query keep on running, is because when you restart the SQL server or when there is a memory pressure, SQL engine will first go ahead and delete the plans which are least recently used. So if that is the case, then you do not have a plan in the cache. Now, if that is the case, then it will go ahead and build the plan again, right? Now, if the plan is already there in the cache, now all right, it will go ahead and take that plan from the cache. But wait, it will have to go through another additional step known as check for recompilation, and this step is especially when you are using query store. Now if you are not using query store, this step won't occur, right? So what will happen once you enable the query store, and let's assume that we have actually forced a plan and that query is running with a forced plan, right? Now it will go ahead and check. Now what does it check? It will go ahead and check whether the plan that we actually took from the cache or the plan that has been built, is it similar to that forced plan, right? Because we are running the query where we actually forced a plan. Now it will go ahead and compare this plan with the forced plan that we saved inside the query store. Now, not every time it might be the same, it might be different. So that's when it will go ahead and recompile again and build a similar plan to the force plan. Now, most of the time it will be similar, right? Now, when it is similar, it will go ahead and move forward. Now, before the query goes to the execution phase, the query text and the query plan will be saved inside the cache. Now, whenever you enable the query store, you always enable certain caches in the memory. Those are known as plan store and runtime stat store. The plan store will save the query text and the query plan. Runtime stat store will save the runtime statistics. But the runtime statistics will only be collected once the query goes to the execution phase. Now, after the query goes to the execution phase, the runtime stats are collected and saved inside this store. Now we have all of this information, query text, query plan, runtime stats stored inside the memory. And now every interval of 15 minutes by default, that information will be asynchronously pushed to the query store schema. Now where does this query store schema live? This query store schema always live on the database where we enable the query store, and on the primary data file of the database only. You cannot change the location of the query store schema. Now that's how the query store actually force the plan. Whenever you force a plan, how does it actually compares and then collect the information? Now what are some of the benefits of query store? As you know, I mentioned that there are a couple of graphical user interfaces that are readily available as reports within your database where you enable the query store. You can go ahead and expand the window Once you enable the query store, you will get a separate folder with mentioning query store, and then underneath that you get all of these reports. These are the reports where you can see how what are the top resource consuming queries, and did i did I force any plans, and if I force any plans, I would like to see all them in one report, all the force plan in one report. You can see that using queries with force plan. And other queries like query weight statistics, tracked queries, you can track the queries. If you wanted to look and track any specific queries, you can also do that. You can see the regressed queries, performance regression in the queries, you can see those, and queries with high variations as well. Now that those are only the reports, but you can quickly fix the non-optimal plan usage by forcing the plan which you think is working fine. You can force the plan very quickly with couple of clicks, and it helps the performance tuning. Um, it will help performance tuning your queries pretty easily without touching the code, right? Because you force the plan or you use automatic plan correction to fix your problems, um, until you finally decide to change the code itself to figure out what the actual problem was. And as no code changes are needed to the user, whenever your application, like you might be having, like if you wanted to change some code, you should be getting the approval from vendors, or not all the time they agree to that, right? In that case, query store will really help. So I used personally, I wanted to put this slide together because personally I used query store especially to capture the baselines while doing the upgrades of the databases. Now, how does that process goes? Because I'm a DBA, I would like to help developers to, help them so that they can know the queries better. Once they do the upgrade, once we do the upgrade, if there are any hiccups with any certain queries, they will know it very quickly by using this process. So what we do is, first we will upgrade the database. We'll upgrade the database, let's say from 2016 all the way to 2019, let's say. And then once we move the database to 2019, we will actually do not change the compatibility mode of the database. We will still keep the compatibility mode as 2016 in the new environment. And then we will go ahead and enable the query store. Now, once we enable the query store, it will go ahead and collect all the information. We will keep that enabled on the oldest compatibility mode itself on the new environment, just like running like the old database, right? Just to capture the baselines. We run all the queries, no matter how they perform. Most of them should perform well, but there are here and there some queries will go drastically down after we upgrade, right? So we'll collect all of the information, and once we know that yes, we did collected all of most of the information, now we'll go ahead and flip that to 2019 compatibility mode, the latest one, which is on the new server, right? And then we will go ahead and run the queries again. And now if we have any queries which are not running fine, we have the ability to go back and see, how does this query used to run in the old environment? Now I have that information on my new environment itself. Now I have that execution plan. I can go ahead and see. Now we as we capture that execution plan, you can force that execution plan until you figure out what was the actual issue, right? That's how I at least fix 3 to 4 queries upon my upgrades, and we do this as a standard on every single database that we upgrade. So, as I mentioned, the automatic plan correction is nothing but an additional layer of advancement to the query store. Um, Instead of you actually manually forcing the plan, you give the SQL engine or the Azure take the take that step for you, make that step for you. It will always go ahead and learn the workload and adapt, and watch out for any regression in your queries, and then it will always make sure the last good plan is always forced. Now, if you are getting any low performance queries, building up new execution plans, It will always compare them and always make sure it will automatically force that for you. And also an advancement in SQL Server 2022 and in Azure SQL is query store hints. Now, query store hints are very much similar to your regular query hints. But the thing here is, if you are having any, let's say, if you are having any parameter sensitive problem, and if you can't change the underneath code for any reason, um, and you have a execution plan built in the plan cache with a wrong parameter, and now you wanted to somehow fix the problem. Usually what you do is, if you're a developer or a DBA, you usually go ahead and recompile, right? You'll force the SQL engine to generate a new plan with a new parameter that you're passing in. But the thing is, you do not have to do that. You do not have to touch the underneath code if you take the advantage of query store hints, because with the query store hints, you are going to use specially designed store procedure where you pass the two parameter values into it. Number one parameter is a query ID, and the number two parameter is the hint you wanted to use. And like for example, you can do recompile, max stop, minimum maximum memory grant size, as well as the compatibility level. You can use the compatibility level specially to any particular queries as well by using the query store hints. Now, before moving to the query store advancement, let me show you the demo actually. So there are couple of important things that we have to know on how to configure the query store. It's not like just knowing what query store does, but it is very, very important to know how to actually configure. Because if you do not configure it properly, it will blow up your query store, and it will fill up the query store very quickly. And also it will take automatically, it will go into the read only mode where it will not collect any further information, right? It will still read the data, it will still read your forced plan information, but it can't actually insert any data into the query store. We do not want that. So I'm going to show you in this demo how to actually enable the query store. So we are taking Stack Overflow 2013 database here. It's SQL 2022. So I'm going to do the read write mode. So there are certain operation modes here. Let me show you. So once you right click on the database, go to properties. From SQL Server 2016, you are going to see this option, query store, on every single database, right? And then if you see there are operation modes, if you hover your mouse down, if you click on this, it says like read only mode and read write mode. What is read only mode? Read only mode is only when you are allowing the query store to just read any forced plan information, but not to write any information into the query store. It will read every information, but not, it won't write anything. That's read only. Read write mode is it can read the force plan information as well as write the new query information, all the statistics information into the query store, right? That's the, and if you turn it off, you are just shutting off the doors of query store. That means like nothing will happen. It's just like a regular database. Now, mm, what are the other things that we have here? Now, as I mentioned, we have flush out intervals, right? Flush out intervals are by default, it is 15 minutes, but I changed that to 50. But what this interval does is like it will collect all the information, like you have seen in the diagram that I showed you. It will collect all the information, and then every 15 minutes it will push that information into the query store schema. But sometimes what happens is, even before hitting the 15 minutes, there is a there is an ability for that flush out interval to kick in and push that data, is because whenever there is a memory pressure, the all of this information will be flushed out to disk. And every there is a statistics collection interval as well. It is by minute, it is by default 15 minutes. But the thing is, every interval, Like for example, for every 15 minutes, a new interval will begin. And in that particular interval, in every interval, for example, let's take the interval number one. In that interval number one, let's say you have a query which will run like 100 times in a minute. Let's say there is a this sensitive query that has to run every 100 times, right? Let's say. So no matter how many times it runs within that interval, it will only capture one record in that query store. So you need to know that it's a collection of the statistics. It's not a cumulative information of the statistics, not like the independent to each run, right? And maximum plan per query is by default it is 200. You can change that, but do not go less than that because we need 200. 200 is a good amount. And maximum size is 500. I put it as 500, but from SQL Server 2019 I believe they changed that to 1 GB. So start with 1 GB if your databases are small to medium, but increase the size based upon your needs. You can choose that value actually. Query store capture mode, there are certain capture modes if you see. Now if you choose capture mode as all, which is by default it is all in SQL Server 2016, but from 2017 and above they changed that to auto as default. Now why is that? Because if you choose all, then it will collect every single query, even the insignificant queries, ad hoc queries, everything will be collected. But if you choose auto, then a SQL engine will check for how many times the particular query have to run, what CPU threshold it have to hit to capture that information into the query store. And now that statistics, what sort of how many times the query have to run and what CPU threshold, we do not know that information. That is Microsoft decided information. We do not know that, and it is not available online. And if you choose none, then it will not collect any information. But if you choose custom, like I mentioned, we have the custom policies enabled from SQL Server 2019 and above. Now, if you choose custom, then you can choose all of these options. What is the execution count? How much is tail threshold? And what is the total compiled CPU time? And what is the execution CPU time? You can give that information and capture only certain queries, not all of them. And there is also this query threshold. Uh, Query threshold is 30 days. By default, it will go ahead and clear out any old data that is not being used. It will not touch any forced plan information. If you have any forced plan or if your automatic plan correction has actually forced a particular plan, it will not touch that, right? Only the old, not read data or like not usable data will be deleted. Now, wait stats capture mode is turned on from SQL Server 2017 and above. And like if you are in SQL Server 2016, this is not available. So it is on or off. That's all it is. So those are the values that I put it here. You just need have to alter the database and put all the information here and then execute the query. Now that's how you can actually enable. I was like very specific in explaining each and every one because this is very, very important. Now to know like what all options you have, or like to see how the all options that you enable, you can run this actually view to see that information. It will provide that information like what all you selected and what are those values in detail here. And let's run this one and see if we get any data. So once it captures the information in the query store, it will actually, you can use these sort of queries like views to get that information. Query text ID, query text itself, plan ID, query ID, all of that information. Now let me go ahead and show you how it will actually look um, within this query store folder. If you expand and then top resource consuming queries, right click view top resource consuming queries. Now did you see this? My automatic plan correction is automatically enabled because I'm using SQL Server 2022. It's a automatic plan correction enabled. This is my enterprise edition of SQL Server. So it has actually forced this plan, and that is the reason why you are seeing a little tick mark over here. But I do not want to see it in the bar graph. Now, if you are using bar graph, then you have to hover your mouse to see the query. And if you see the query here, it is in the parameterized format. If you are running any store procedures and that store procedures are being collected here, please remember that the store procedure text is shown, but it is always parameterized. It will not show you the value you have passed in. You need to remember that. And now I want to see it in the table format. So I will be clicking on this view top resource consuming queries in the grid format, which will give me the details of like query ID, object ID, for example, object name. We did not run any particular object. We just ran random queries. So um, that is the reason. So we can, for example, let me also mention this. For example, you have a store procedure. That store procedure have 10 different queries in it, let's say. So how does the query store capture that information, right? The object name will be the same. It is a store procedure name, but the object IDs can differ based upon the query value. Like if you are saying these are the queries, let's say these are the three queries in the store procedure, you will have the same object name, but a different object IDs all tied up to the same query ID. So, um, so that store procedure will have different, it will have the same object ID, sorry, because um, the object name is similar, right? The store procedure. But the thing is, like all of those queries will be collected and tied up to the um, same object name. That is what I mean. So mm, let me go ahead and show you the other. Um, I think that is what I wanted to show. And then if you hover your mouse over here, it will also show you the total duration, execution count. Sorry about that. Execution count, how many times your query has run, and the plan count, all of that information. And also, some of the important information you can see are like if you click on one query, you can see how many plans are getting generated, and each plan gets its own plan ID. Now, this particular plan is being forced by automatic plan correction, but you can actually unforce or force the plan by using the button over here. Like if you unforce a plan, it will ask you, do you want to unforce a plan? If you click S, it will go ahead and unforce the plan. Now, if you want to force a plan, click on force the plan, and it will say like, do you want to force this plan for this query ID? If you click on yes, it will go ahead and force it back again. But if you force and unforce a plan by using this particular graphical user interface, this information might or might not be collected by using the monitoring tools. So try to use the um, store procedures to force and unforce plans. And the other thing, the other metric that you have to know here is all these metrics. By default, it will go ahead and show you by duration in milliseconds. Now if you hover, it will show you the duration, average duration, minimum duration, maximum duration, total duration, and how many times the query executed, those sort of information. But you can go ahead and change to CPU time. And if you hover your mouse over here, it will show you the CPU time information. And you can also see the statistics, average, max, minimum. And also, if you click on this configure option here, on the right top corner, you can see all of the stats that you can filter that we have seen in the metric under the metrics as well as stats. But then the other thing is time interval. You can go ahead and see by default it will get the 1 hour interval, but you can go ahead and see last 5 minutes, last 15 minutes, and you can also customize and you can choose from which date. Like for example, you had a query problem that happened like 15 days ago. You can go ahead and change the timings from and to, and then you can change the time format as well, and how many queries you wanted to see. You can see, you can set that up and click on OK, how many minimum number of query plans you want, and hit apply and click OK. It should get your information. It should get that information. So those are the important ones you need to know when you are looking for the query store. And since we apply the force plan here, we can actually go to the queries with the force plan graphical user interface. And this particular query ID is being forced. So the color has changed. Do not depend upon the color. The color can change anytime. You can close, open, it can appear different color, but you can see the plan ID. Go with the plan ID. And then if the circle is looking bigger, that means those many times you have executed. If the circle looks smaller, then less amount of times the query executed. If you are seeing a triangle, that means the query has actually you have actually I think there are two more options where it can show triangle and square. If it is showing square, then that means like you have aborted the query in between, you have stopped the query. If you are seeing triangle, that means the query has actually failed. So you can see three options, right? You need to also remember that. So I would also like to show you before closing this demo. I would also like to show you how I actually use the query store in the upgrade scenarios to capture the baselines, right? So I'm using Wide World Importers database, which is 2019, I believe. So I need to um, connect it to my 2019 database server. Mm, Let me see, this is the server. Now I would like to enable the query store and free up my cache. And let's assume I have actually, this is 2019 server. So let's assume that I bought this database, I migrated this database from 2016 to 2019. And I have altered the database, set up all the query store configuration that we discussed. And now I'll go ahead and make sure the database is in the 2016 mode, the old compatibility mode, right? And then let's say we have a store procedure. Now I'm recreating it here, but then let's assume we already have that stored procedure and we migrated that database. This is a very simple store procedure. A couple of selects, inner join on a different table, and then searching on the quantity. So let me go ahead and execute this. All right. Now I'll go ahead and clear out alter database, clear out my query store. To not do this in production, it will completely wipe out all the information from the query store. I'm also doing free proc cache. Now why I'm doing this, because I don't want my demo to break, right? I'm showing a demo to you, so that's why I did that. So now we have created the store procedure. Now I'll go ahead and run this workload on my new environment with the old compatibility mode on this database. Let's execute that. Meanwhile, let's open the query store. Top resource consuming queries, right? I want to see it in the table format, right? We have this plan ID 1. All right. Now I'll go ahead and I'll let's say we already completed executing all of the queries. Now I'll go ahead and update my compatibility mode to 2019. Now I did that. Now I'll go ahead and again run the query. I do not know how it will perform. It should perform very nicely most of the times, but I do not know. Now let me go ahead and refresh this button. So if you see here, right, we are checking on the duration. Let's check on the CPU time. Now the query ID 1, it is taking long time. It is taking like a total CPU time of 46 milliseconds. But the second one, if you hover your mouse, it is doing just 10 milliseconds, which is a great improvement after the upgrade. Now that is how it is supposed to be, but there can be scenarios where this will be reversed. Like the next execution can be totally different. Now, what if you want to compare yourself and see? You can go ahead and compare the plans by clicking on each of the plans, click shift and click on each of the plans, and then compare the button here on the top, compare the plans. By clicking on that, you can actually compare between the plans. Now, anywhere that it is not showing as not equal, meaning they are equal. Now, anywhere it is showing not equal, that means that those are the differences. Now, you can compare the differences between the plans and all of the stats information that it shows here, and then you can see how the query was performing. If there are any missing indexes, do not just run away with these index recommendations, because you need to know if that index is already there. Sometimes even if it is already there, it will show up, right? Now you need to know what is the impact. If there is no index, then go ahead and create and see the impact. Did that improve the performance? Those sort of things. Now that's how we can actually, once we do the upgrade, we can know the difference, like if there are any differences in the query executions. Now let me go back to my slide. So we have 3 more minutes, so I will cover as much as I can. So there are certain advancements, right? So one of the advancement is like anytime you are creating any new database, query store will be enabled. But if you are migrating from the old environments, and if you do not have query store enabled on the old environment and you are moving to 2022 SQL Server 2022, you need to manually enable that. And um, query store hints are available from SQL Server 2022 and in Azure SQL. All of these demos that I have been showing here clearly applies to Azure SQL as well. You can connect to the Azure SQL by using Management Studio, and you can see the similar kind of environment, and or you can take all the advantages of it. And um, IQP features, intelligent query performance features, which are introduced in SQL Server 2022, they use query store to capture the information. They actually monitor and adapt to all the changes, and they will see the workflow of your workloads of your database, and then make decisions on the top of it. And to enable these IQP features, all you have to do is make sure it is in the latest compatibility mode, which is SQL Server 2022. So highlights of these AQP features, all that you have to do is make sure you have SQL Server 2022 or compatibility mode, and these IQP features can use Query Store and make decisions for you, automatically make those changes. You do not have to make any of those changes. Those changes will happen internally on the engine itself. So query store for secondary replicas. This is in the preview mode only. So if you are using high availability, always on availability groups, um, again, this is a preview feature, but the thing is like it will go ahead and collect the information not only on the primary, but also on the secondary read only. And it will send the data, it will collect the data on the secondaries and then send over the data to the primary. Because as you know, read only secondaries are only read only. You cannot make any changes or like do some configurations on the secondaries. Anything you do, you need to enable it on the primary. So I have placed these things here, how to enable it. So anything that you wanted to enable, especially for the always on availability groups, you need to first enable the query store on the primary read only. Then you can go ahead and choose the operation mode, and then go ahead and connect it to the primary replica and run on each desired database. So if you want to add on the secondary, alter database name for secondary, set query store is equal to on, and you can also choose operation mode. Now to disable, you would do like alter database name for secondary, set query store to be turned off. Now, how to unforce and force the plan on secondaries. Now, until now, we have just two options that we need to force and unforce the plan. To force the plan, you use execute sp query store force plan and give the query ID that you will be captured from the query store. You will get the query ID and then plan ID. But if you observe here carefully, there is also a third parameter. Now, what is the third parameter means, right? If you are using the plan forcing on the primary, secondary replicas, there is this third parameter, and that parameter means you can either use 0, 1, or 2. 0 means you force on the read write replica by default, on read write replica only. There are no secondaries. But if you use one, you force or unforce on all the read only replicas. If you use two, then it will force or unforce on all the replicas. Now, there is something which is important that you have to know. Since the query store will also capture ad hoc queries if they fall into the if they hit that threshold limit of CPU, it will go ahead and collect that information. Now, it might blow up your query store, fill up your query store very quick. If that happens, query store will go to the read only mode, and you have to know that, right? So there is this link that I posted here where you'll go ahead and copy that code, which is a Microsoft doc code. You'll copy that code, create a job where it will run frequently, so that you do not have that query store do not have to go to the read only, because it will keep on purging the ad hoc workloads. The best practices are like, do not drop your objects. Um, but do not drop and create the patterns for containing objects. Instead, use alter. Like if you wanted to alter the store procedure, do not drop and create, because if you drop and create, that will create an entirely new query ID. And until then, you have a different query ID, and dropping and recreate will create an entirely new query ID. And until then, if you collected any information on the queries on that particular query or a store procedure, then that will actually that information will not be any more useful, because uh, it got a disconnected with a new query ID, right? It got a new query ID. So do not do that. Avoid renaming the databases for queries with force plan. If you have a force plan, do not rename your database. Usually we don't do that, right? Once a database is it's being done, it's done, because everywhere we are using the database, all the applications. So usually that is not a big issue. We don't do that usually. So but there are two trace flags that you have to remember here, is that usually when you are restarting the SQL Server for any reason, right? You did the patching or stuff. If you are restarting, then what happens is usually all the collected information in the memory first have to be pushed to the query store schema. That might take a, any number of minutes depending upon how much data you have in the memory related to that query store. So that might take time. Once that is done, then SQL Server will restart, and you do not want your applications to have so much of downtime, right? Not even few minutes is acceptable. So enable this trace flag 7745 so that it will avoid writing to the query store data. Again, you need to be okay to lose that data, because now once you enable this trace flag, SQL Server will immediately get started and it will pull up your databases online. Um, but the thing is, like, you will lose that data which you collected for that certain interval minutes. And another trace flag that you need to know is trace flag 7752, which will enable asynchronous load of query store. Now, once you restart, the databases will be coming online one by one, right? So when they come online, and if you have the query store enabled, then it has to actually pull in some system information related to query store into the memory first, and then start the database. Now, even that can take certain minutes to start your database. First, pull that information into the memory and then start the database. Now, we do not want that. We can actually start the database and then move the data into the memory. So trace flag 7752 will do that. It will actually take it online and then pull the information into the memory. Now, by default, it is being enabled from SQL Server 2019, and it is automatically enabled in 2022. So if you are using Query Store and if you are in the lower environments, please go ahead and safely enable this trace flag. Some of the things to remember: any query hints in your code will override if you are using the query store hints, right? Query store hints are persisted even upon the restart. Table hints are not supported in the query store hints. And overrided hard-coded statement level hints and plan guide hints. Any of these will be overridden. If underlying schema changes, the automatic plan correction will unforce the plan. Now, what is underlying schema changes? If there is a plan that is being forced, right, by the automatic plan correction, now you went ahead and dropped that index that is being used in that force plan. Now, as there is an underlying schema change, which is a drop in index, automatic plan correction will automatically unforce the plan. You need to be really careful of changing any objects within the force plans. And these are the resources that I would like to share with you, that I used to prepare my presentation. And if you have any questions related to this session, because I did not give a break in between, I know. I'm sorry about that, but there is a lot of content to cover. So that was a reason. And if you'd like to contact me, these are my profiles, and I would like to thank you, Daniel, one more time for giving me this great opportunity to speak at your user group.
It was a pleasure of having you. It was indeed a lot of content, and I must admit, you sometimes lost me a bit because I'm not a DBA. I'm an Azure infrastructure person, so um, this some things were new to me, but I definitely learned a lot. I also had a look at the chat in in YouTube, but there are no questions there yet, anyway.
Mhm.
So indeed, if people have questions, please contact Deepti and
Yes,
ask her the questions yourself.
sure.
Thank you so much for your time.
Thank you so much, Daniel. You have a great rest of your day.
Well, it's evening here, but
Oh, it's
thank
evening, so good night.
yeah, thank you so much, and we see you all next month. If you
Yes,
like this,
sure.
please subscribe to the channel, and you'll get updates when we schedule new live sessions. Thank you, Deepti,
Awesome.
and enjoy your
Thank you
day.
so much.
Bye
Really
bye.
appreciate it. Bye.